Hello, my name is Stefan, and today I'm going to tell you how to create a dungeon generator in Unity. Damn. But before we start, here's a quick overview of how our program will function. So we will start with a big room that we will later divide until we reach a certain space limit. After that, the leaves of this, in this case a tree, will be added to a list of rooms. Also, the classes will be divided in ones that are responsible for the logic and ones that are responsible for the visual. The logic classes will of course be responsible for things like data structures, the generate functions, and the events that will be called for each step. And dependent on the logic classes will be visual classes that will be responsible for object spawning, the color, size, and other visual variables. So hopefully our final result will be something like this, where each room is randomly sized and connected, and the rooms that are not connected will be destroyed. So let's start by creating the dungeon logic and visual classes. Let's access the room class first. It shouldn't be a mono behavior, it's just a data structure. And for now, I'm not sure if I want to add new things, but I'll create a custom struct called room area. Then we will hold all the data for the rectangle. And right now it will only have the room area. Create a constructor for both classes. Let's access the next class, which is dungeon. Back to the drawing board. The way this algorithm will work is that you will have a queue. First, you enqueue the big room, and while the queue is not empty, you dequeue the one element. I didn't dequeue, whatever. Then you split it, and then you enqueue the new split rooms into the queue. Nice. And then you just continue. So this time you will go to number 2, you dequeue it, you split it, and then you enqueue the new items. Wait, oh yeah, I made a mistake here, so this is how it should look like. So let's continue. So the first one will be the minimum size of the dungeon. Min size. Then we have the list of the rooms. Now it's good. So let's make the function that's responsible for generating. And for it to work, as we said earlier, we need a queue. In the generate function, as we said earlier, we start by creating the original room. Oh, for that we need the room's width and height, so the big room width and height. So let's create the room. So we create the first room and we enqueue it to the room that enqueue, and we start our loop. Look how smart he is now. To do rooms.dequeue, and let's call it current room. Okay, so now we want to check if we can divide the room. For that, I'll first make helper functions. These are mostly for readability. So this is how you would split it vertically. This you would split it. You split it horizontally like this. Return room dot area dot width minus min size bigger than the min size. This will make things uniform also. And let's do the scan split horizontally. So the min size, the way it will work is that you have just a number, and it will be both the minimum width and the height. So for this room, for this minimum size, the minimum possible size would be this, and it would be something like this, right? This small. So no room can be smaller than this square. So if we can split vertically the current room, I think it's better to just do it straight away randomly. I was thinking of making it just in half, but that doesn't really matter. But to make it random, I will create a helper function. I want to use the system random class because you can use a seed for it. So first we want a seed, I guess, int seed. Let's make this a variable, and let's create a random object. This will basically says that we want to use the one that comes from the system. So we have this, and in awake, I guess we instantiate it. The way it works is that if you want to get a float, you get a float double between 0 and 1, but we want it to be in between a range. So let's make them as parameters. And to be honest, I just copied this function from the internet. I don't want to think too much about it. We want to get a random width, get random float. So the random width shouldn't be smaller than the minimum size, and also we should subtract it from the overall width. So because it's basically the same thing, we want to take from the range in both sides. So this should be minimum size, but you also want to subtract from the width the minimum size. So we can only divide it here, so that if we divide it, neither the left or the right side will be smaller than the minimum size. And now we just actually divide it. So in our version, the pivot or the origin point of rectangles is on the corner. So the rectangle is here. Some games and actually in Unity 2, the origin point is in the center, but in our algorithm, so everything is nice, we have it here. So this is 1 1. The rectangle has the position 1 1, and it's displayed like this. In Unity you would have it displayed like this. This is 1 1, so it would be shifted to the left, like so, if it would have the pivot in the center. Okay, it would have the same position as the room area dot x, current room dot area. Now let's make a room area so we don't have to write it all the time, right? So the width of the first room will be random width, this one, and the height will be the same as the room that is being split. But for the second one, we want to add here the random width. So let's imagine that we split, so we decided the random width to be somewhere like here. The first rectangle, you would position it here, but the second rectangle, you would so this is the second rectangle, you would position it by this position plus the random width that we chosen. And the height, as you can see, is the same for both rooms. In this case, we want to subtract from the room area width the random width. So I mean, I guess conceptually it's pretty obvious, right? You have this width, the first rectangle has this random width decided, but the second one has the whole things, whole rooms minus this width. So you would have something like this, yeah. And now we just enqueue both rooms. Else, if we can split horizontally, we basically did the same thing, but goddamn, for the horizontal direction, I think we just copy paste it. Classic. Just call it accordingly. Okay, we keep the width. We want to change the height. We run height. Keep the next position. Change this one. And let's not forget the height over here. And if we can't really split both vertically and horizontally, that means we can't split it anymore, and we are at the end. So we just add the current room to the finalized list, like this. Oh, actually I forgot to mention, here we check if the height, so room area dot height, is smaller than the width. Combine it. So this means, okay, if the height is smaller than the width, then we divide it vertically, so we divide it by the width. If it's the other case, we divide it by the height. This will make things a bit more random and uniform. Okay, this should be actually done, and sadly we can't test it right now. That's why we need to create so to populate this class, make it functional. But to actually visualize it, we need some sort of base, so prefab. Game object, room prefab. In my case, I will just create a square and that's it. But you can do whatever. Your imagination is your limit. We want to loop through the final rooms. So for each room, we want to instantiate the prefab, and the parent will be us, so transform. Nice. So we have the room object. Now we want to change the scale. This will actually expand it in both directions. So because the pivot point is in the center, the scale will increase it like so, right? But we want it to behave the same way our logic rectangles are scaled. So like this. There's a simple trick for that. So let's just create prefab. Boom, prefab. And inside it, we will put the actual visual. Oh, not in UI, it's in sprites. Square. Visual. Let's make it a color. So yeah, and we want to change the position of this to be at 0.5, 0.5. The reason for this is if you played, for example, around with Unity and you try to scale things, then place them somewhere, you might have noticed that it's not so easy because it expands in both directions, and then you kind of have to find out how far it expanded to the left, then kind of offset it by how much it expanded and stuff like that. But if you just place the object at 0.5, 0.5, so this is the axis, right? Before it was like this, so when the whole space expands, the object expands like this. But if you put it in the corner, if the space expands like this, then the object expands like this. If it expands like this, then the object will expand like this, right? So you would not need to calculate it by how much it went to the left and offset it and stuff like that. Okay, this should be at 1, and we don't want to touch this at all. We want to scale only this. So you see how it goes to the left and right, up and down. Pretty neat. Nice. And now that we've done the prefab, let's place it here. Oh, we didn't save this one. So we have the prefab. This should be good. Oh, and let's actually call the create function. And here in Dungeon, we want to call the generate function. So you notice how this one is in awake and this one is in start, so you don't get conflicts and stuff. You can also make events. Maybe I will do that later, so it creates exactly after the dungeon generates the data. So let's put the dungeon over here. Let's put, I don't know, the minimum size to 1.2, and the width should be like, the big room width should be like 1010. Now I realize that I can call this dungeon width, but whatever. So the seeds, we don't care about the seed at this point. And let's put the prefab, boom. Hopefully nothing breaks. Ah, okay, you see a big square because they are basically right next to each other. Let's subtract some from the width. So let's just make it a bit smaller, 0.1f. So we can see the margins and stuff, the borders, whatever. Nice. Nice. Here we have it. This little thing right here is the prefab that I didn't delete. Nice. So now we have a square divided more or less evenly, and you can do a lot. You can expand this, so basically if you want, the smaller the room is, the smaller the chance for it to divide. So you maybe have a big room in the center or somewhere. You can also, yeah, you can play a lot with chance, and I think in the next episode we will shrink, no, we will add doors, so connections between each rooms, and then we will shrink the rooms so they are even more random in size. Okay, if you like the video, just thumbs up. That will show me that I should make more of these. And yeah, tell me how you implemented it, where you implemented it, what changes did you do to this algorithm to make it fit your liking. Yep, see you then.